Okay, we're doing some factorizing here, and we have two very specific types of problem. You notice when we're trying to all of these ones down on the left, you'll notice that the quadratic coefficient 3 plus the constant number 2 add together to 5. Similarly, 7 and 2 adds to 9, 13 and 3 adds to 16, and 5 and 2 adds to 7. Okay, so a very special thing as a methodology of solving these works out, where you simply bring the 3 and the 2 together in the first binomial, and you have always got x plus 1 in the second binomial. Okay, so I'm arguing that there's going to be an x plus 1 everywhere here. Okay, I'm leaving 2 of them extra for you to do for homework on top of this. Okay. So now we did in class how it arises by working it the other way. But we're going to have 7x and 2. You could say that we'll drop that 2 if you like, and we'll keep that 7x. Okay, so we'll have 7x and we'll keep that 2. X plus 1. We'll have 13x without that 2. And we'll have 5x. Okay. And sure enough, if you multiply it out, you'll get 2x and 5x adding together to give 7x. Now a slightly different question going on over here, where now the center is not 5, the center is 2 times 3 plus 1, the product of the quadratic and a constant, giving 7. Okay? And in that case, you might remember we talked about taking this word prod and turning it into D-R-O-P. So what we do is, if we can make our two brackets, our binomial product, the same width as the original trinomial, then we literally drop that 2x there, drop the 2, drop that 2x in there, and drop that 3 in there. Okay, that's half the battle. Then we want the rest to be units or monomial. Monomial just x squared, x cubed, unit just 1. Power 1s on everything else, and it's coefficient 1 on everything else. Okay, let's do another one. So 5 sevenths is 35 plus 1 is 36. So that means it's a candidate for this special solution. So where 7 goes there, straight down, 5x goes there, straight down. That leaves me filling in the gaps. Well, you can see now that this is going to happen all the time. Okay? And our cookie cutting kind of technique could come in, where we'd say, so that means that's going to be on everything from here down, because they all follow that pattern. Okay? So now that 3x is going to drop in there, and that 5 will drop in there. Now why does it work? Well, that will always be 1x, which is the plus 1 we're talking about up here in the product. And this will always be the product of the two outsides, because they've both been left fully to the outside. All of the weight of the prime factorization, the prime product, has all of the weight of the number has been left on the outside. And they don't have to be prime numbers. So for example, we could have 20x squared here and 15 here. Neither of those are prime. And as long as we got 20 15, so that's a little bit of a mouthful, but we have 300, but then I would have to go up to 301. So if you do that problem, the answer would be 20x plus 1, x plus 15. 15 dropping straight down, 20x dropping straight down. Okay, I left 2 extra questions. So if you follow this and you keep pausing, you should easily have it figured out.